Stop everything you're doing right now, because the reason you exist should be mathematically impossible, not metaphorically, not philosophically. Literally, by the laws of physics as we understand them, you should not be here. The chair you're sitting on should not exist. The planet beneath your feet should not exist. And the fact that any of this is real is one of the most disturbing unsolved mysteries in all of science. Let's talk about the Big Bang. About 13.8 billion years ago, the universe exploded into existence from an unimaginably hot, dense point. In those first fractions of a second, we're talking 10 to the power of negative 43 seconds, energy began converting into particles. And here is where things get deeply uncomfortable. Every single time energy creates a particle of matter, physics demands it also creates an equal and opposite particle of antimatter. Not sometimes, not usually, every single time. This is called charge parity symmetry, and for decades scientists treated it like an unbreakable law. For every electron born, an anti-electron, called a positron, must also be born. For every quark, an antiquark. 1-to-1. Perfect balance. No exceptions. So do the math with me. If the Big Bang created equal amounts of matter and antimatter, and if matter and antimatter annihilate each other on contact, releasing pure energy, then every particle of matter should have found its antimatter twin. Everything should have canceled out. The universe should have been left with nothing but a vast ocean of light. No atoms, no stars, no galaxies, no planets, no people. And yet here we are, sitting inside a universe packed with 10 to the power of 80 atoms. Galaxies stretching hundreds of billions of light years across. Life, consciousness, questions. Something survived the annihilation event that should have erased everything, and we have absolutely no complete explanation for why. Now here's where it gets even more unsettling. Scientists have found tiny cracks in the symmetry. In 1964, physicists James Cronin and Val Fitch discovered something called CP violation, proof that the laws of physics don't treat matter and antimatter in perfectly identical ways. They won the Nobel Prize for it. And in 2020, the T2K experiment in Japan found further evidence that neutrinos, ghostly particles that pass through matter almost without interaction, might behave differently from their antimatter counterparts. This is significant. This is real data pointing toward a real asymmetry. But here's the controversy nobody in mainstream science likes to fully admit out loud. The amount of asymmetry we've actually measured so far is nowhere near large enough to explain the universe we see. The imbalance we've detected accounts for only a tiny fraction of the matter-antimatter gap. Physicists call the missing explanation the baryogenesis problem, and it remains one of the three greatest unsolved problems in modern physics, alongside dark matter and dark energy. Think about what that means. Our best theories, the standard model of particle physics, which is arguably the most precisely tested scientific framework in human history, cannot explain why you exist. It predicts a dead universe, and we are clearly not in a dead universe. Some scientists believe the answer lies in something called leptogenesis, the idea that an asymmetry was created in the very early universe through the behavior of neutrinos, which then cascaded down into the matter dominance we observe today. Others point to hypothetical particles beyond the standard model. The Large Hadron Collider at CERN, the most powerful particle accelerator ever built, has been smashing protons together at 99.9999991% the speed of light, specifically hunting for new physics that could crack this mystery open. And CERN's Alpha experiment has been doing something extraordinary. They are creating and trapping actual antimatter, antihydrogen atoms, and studying them in detail to see if they behave even slightly differently from regular hydrogen. The measurements so far show they look almost identical. Almost. Scientists are pushing precision to levels never before achieved, because even the tiniest measurable difference could be the thread that unravels one of the universe's greatest secrets. Here is what makes this mystery truly visceral. Somewhere in the universe, or perhaps in some parallel bubble of space-time, there could be entire galaxies made of antimatter. If an antimatter star and a matter star ever collided, The explosion would release more energy than millions of supernovae combined. Astrophysicists have actually looked for gamma-ray signatures that would indicate matter-antimatter boundary zones in the observable universe. So far, nothing. The observable universe appears to be uniformly made of matter. The antimatter simply vanished. One particle in every billion survived the annihilation. That is the current best estimate from cosmological models. 1 in a billion. And from that razor-thin margin, everything you have ever seen, touched, or loved was built. You are the product of a cosmic rounding error. You are the leftover, the remnant, the improbable survivor of a war between existence and non-existence that happened in the first second of time. And the most brilliant minds on Earth, armed with the most sophisticated instruments ever constructed, still cannot fully tell you why you won. The universe is stranger and more fragile than it appears. And science, real science, is honest enough to say it doesn't have all the answers yet. Follow this page right now, because we are just getting started pulling on threads like this one. Threads that lead to the edges of what humanity actually knows. So let me leave you with this. If one extra particle of antimatter had existed in that first second, none of this would be here. What do you think that 1 in a billion survival tells us about the nature of reality?